Yeah. So this is 65 and 6.3. Yeah. So this problem, right? Okay. And you're like, what? Now, real quick, if k was 2, what's this? 7. So this is just a number. I know right now it doesn't look like it, but we realize if we let k be a number, this whole thing is one number. Okay, that's one thing to realize, because otherwise you're like, that doesn't look like anything we've done before, and I agree it doesn't, but that's just one number. Is that a 1? No. So what do I do first? You just start to attack it. What do you do first if that's not a 1? Multiply 3 by the last number, which is k. And what's 3 times k?
3x.
3k.
Oh.
Sorry, I don't bring the x squares in there.
Oh.
You could, but you. Now here's the part that you got to realize makes this. It looks horrible. It looks like it's impossible, but it's actually almost too easy to believe. And you're like, you got that right. I don't believe that. What are you looking for now? I mean, the process. I really want this to make sense, because I started teaching it this way a few years ago. The process doesn't care that it's 3k. It doesn't care. That's not a 1. You multiply, and then what do? I need what's of these that make what? I need, in general, when I multiply those, I need to find what's.
1 and.
So for example, if it was this, you would do this, and I need numbers that multiply to be this.
Yeah.
So I need numbers that multiply to be this, and add to be this. Well, what adds to be 3k plus 1? 3k
Plus 1.
and 1. And what's 3k times 1? Holy shit. So the factors of this are 3k and 1. Holy shit. And now I can split this up as 3kx plus 1x, because that's the numbers I want to use, right? That's the numbers I want to use. Okay. So give it too much away. So that one.
Again, what you did here? 3kx.
You're missing a k in the middle.
Yeah, I'm a little lost.
Because then
Again, this is step.
All right. You ready?
Yeah, please.
So you ready? You're supposed to be last, because that one's a little bit beyond. So let me put a problem down here that's got nothing but numbers in it, and let's follow what we do. Because again, the process doesn't care. We care. We're like, I care it's a k. What the hell do you do with k? You said, what do you all at k's? The process doesn't care. Yeah, you don't care about nothing, math. But 4 times negative 6. Then I look for factors that add to be this, right? What would they be? 8 and 3. Now just follow what you do, because you do the same thing always if it's in this form, and that is in this form. So the process has to work if it's factorable, right? So then what do I do with 8 and 3?
minus 8x.
Where'd the x come from? Because it's freaking there, right?
Yeah.
So those are the coefficients.
Of x.
That's right. Plus.
3x minus 6.
And then you would finish that. We're not going to finish that one out.
Right.
So what would I do here?
Same.
Those are my numbers that I want to split the middle term up into. So it would be 3x squared plus 3k x. Just like we put the x there.
Okay.
Plus
1x.
1x.
Plus k.
But in this, never mind.
So the x,
never mind.
the x and the k are together. The x is with the 3.
It's exactly as together as the 5 and the 8 and the 3. They're exactly the same type of together. You can pull that apart, of course, right?
Yeah.
Now 3k plus 1 coefficient for x.
Yes,
right?
cool. Just like 5 is a coefficient, negative 5 is a coefficient of x, and
So
I broke that
my-
apart. 3k plus 1 is a coefficient of x, and I broke that apart.
Oh, okay.
Sorry about my English, it's horrible.
So why are we doing screw the x first and then so?
Because we didn't know until we did this that was the right way to break this up. Maybe it was supposed to be 2k plus k plus 1. Because how many ways can you break this up? A lot. It could have been k and 2k plus 1. Don't they add to be 3k plus 1? There's a lot of ways to break it up. The simplest way to break it up is the way it's already there. And that turns out to be the right way to do it. But if we don't do this step, we don't know. You're just taking a guess and hoping. right? And then getting lucky in this case because, oh, it worked this time, but it's not good enough, right? I'm not going to give you points for being lucky. Right?
Can I ask you?
Yeah. I'm sorry. So again, if that problem specifically still doesn't quite make the most sense, that's not the end of the world, because this is a definite bonus kind of situation, but the same process I use here has to work here. Because K is just a number, so that's just a number.
There's no grouping after that?
No, and then you would finish it out. You group, then you finish it out. I want to leave something for you. So there is more steps here. The same steps that would be next year, right? Yes.
Just really quick for like the grouping of that first part, I took an X, is that right?
Exactly. Take a 3 and an X. 11. Kick ass. And guess what you're left with? X plus K. Hey, look, it's going to work. I like it. It's got to work. If that step works, this step's got to work. The grouping's got to work. That's why my teacher, when I was taught, called it surefire method, because surefire is going to work. Southern teacher. Surefire is going to work. Yeah. I'm a Georgia boy, so I'm allowed to make fun of it. Yeah, it's the last place you guess I was born.
Yeah.
Yeah.
Well, I was born in France.
It's been, my accent's been buried. When I go back to Georgia, it comes back out. But then immediately goes, hey, all right.
Are
And
they
then-
have another accent from California? Georgia?
Yeah, they have
I don't know.
way different accents.
Oh, yeah.
A little bit.
A little bit.
A little bit.
Californians are.
You know, they can talk like this. You want some tea?
Like this?
Me, no. I don't quite get it. You got that kind of Southern. You got, hey, how you doing? Come on
Oh
inside.
my God.
And then you got, like I was saying earlier, you got the, oh yeah, let's go. You know, so there's all kinds, and then everything in between. Yeah.
Is there an easier way to do like 7 through 14? Like I got the first couple.
In 6-3?
Yeah, but then I got to like 12 and 13. Like the fact that they already give you 2, like totally screwed with my head. 'Cause
Okay.
I'm trying to,
All right.
Like that does not go in.
So let's just pick one at random, like number 11.
Sure. See if I did it.
Let's see, 6x squared plus 11x minus 7. And they give you, and this is going to become an important skill to have later. Let's see, 2x minus, so this is what they give you. So,
I
obviously,
feel like that one's easy. Can you do one where like they
Uh-oh.
have both?
well, let's do this one first to just get us into the idea.
Okay.
What's got to go here? Because what do I need to have these make? So this has got to be a 1. Now what's got to go here, because I needed to make a 6x squared? 3x. So that one wasn't too bad, I agree. So that was just a warm up. So give me one specifically then.
Okay, 12.
12.
It's not bad.
The next one.
They give you the same at the back, so it could be anything.
Oh yeah, so they give you the last 2. So they give you, where'd it go? Minus 7.
And minus 4.
And minus 4. So that's all they give you in the book, and you got to fill in the blanks. So this one I agree. This one is almost, so wait, did I write that? Obviously I wrote that down wrong. Can you guys see why?
Plus 7.
7 and 4 make 28. Cool. All right. Otherwise it won't make any sense. So you need these 2 numbers that I'm going to put here in front of x have to do what? Multiply to be 6. And when I multiply whatever's there and add it together, it's got to make negative 31, right?
Yeah.
Okay. So one way you can do this is just to guess and check, which they don't say that it's not right to do that, right? So one way to do this is like, let me try 2x and 3x. Let me try 6x and x. Let me try 3x and 2x. Turn it around.
I was okay.
That's one way to do this. And that might be the easiest way, because the other way is a little bit strange. It's almost like you have to just do the problem and then figure it out. But here, I mean, you've got a lot of stuff done. So if I put, like, for example, if I put 2x and 3x, what do I get? Minus 21. Do you see that? Minus 21x. And I get minus 8x. Does that make 31?
No.
No. So that can't be it. Maybe it's 3 and 2 instead. Do you guys see where I'm getting my guesses from? I mean, it's got to be 3 and 2, or 2 and 3, 6 and 1, or 1 and 6. There's only 4 things to try. So So I mean, that's perfectly valid for those problems. It's just the guess and check.
Okay.
The skill, the reason I'm okay with that, because normally I'm not good with guess and check. I don't like it, but it's making you realize to check, you got to put everything together to see if it's 31. That's what you got to realize when you do that. So I'm okay with that. All right. Did we try that? So 12 and 14.
No.
They don't make. So yeah. So it's got to be 6 and 1 somehow.
And
You can
X.
try this.
X.
That's 24 and 7. 24 and 7 make
31.
Okay, cool. Yeah. So that's how you can do that. Yeah.
I just okay. That's what I was doing. I just
You wouldn't think that it would be harder if they give you some of the answer, but yeah.
Okay.
Okay.
Okay. Thank you.
Sure. All right, guys. One thing I want to say about, I finally got homework, which is really, really good. I was really happy. But then it didn't go so well. The Chapter 5 homework for the ones I checked. Some of the ones I checked didn't go so well. So, like terms is huge. If you can't get like terms, then that messes everything up. Because like terms is a part of almost everything we do. So if you really had a rough time with that homework, you got to come see me. Or ask questions in class. You know, you got to do one of those two things. That's why I was concerned. That's why I told you the other day I'm concerned I haven't gotten homework, because that's the way I can gauge where you guys are if you aren't asking a lot of questions. That's the only way I can see where you are as a class versus a quiz or something, right? Okay, so that helps me out when you do the homework. All right, so let's review what we did yesterday. Oh, you know, while I'm thinking about it, well, let's do this. Let me remind you. I call this step 0 very often, but when I'm factoring, what's the first thing I try? All right, you guys are like sick of me saying that, but oh well. Once you try GCF and it works or doesn't work, you then look at what? What do you look at?
Grouping.
No. Why would you do grouping if there were?
How many terms do
So
we
you
have?
look at how many terms. So if there's 4 or more terms,
Grouping.
grouping. By the way, if you don't want to write this down, don't, because I'm going to give you a little handout. But I just want to remind you, so when I give you the handout, it makes a little more sense. 4 or more terms, grouping. 3 terms, what do you do?
Multiply the.
Yeah, if you have to. So if that's a 1, it's easier, right? If A is 1, then it's just make the numbers work, right? They have to multiply to be the last dude, and they have to be the middle dude. No big deal. Not too bad. If A is not 1, that's where you got to do A times C, and then, right, A times C, and then do that whole surefire method. And then the thing we just talked about yesterday was, what if there's 2 terms? Kind of makes sense. 4 terms, 3 terms, 2 terms is next. So what could it be if it's 2 terms? What could it be? If I have 2 terms, what form could it be in? I liked it. So the middle term's always going to be 0 if there's only 2 terms, right? But what form could it be in?
Foil.
Maybe difference of squares. Okay. All right. I want to get you guys started. Difference of squares, which is a thank your favorite deity problem, right? Because all you got to do is cut it in half. So if you notice what form it's in, you then know what to do. Very often people just start to try something and they obviously didn't stop to think about what form it's in. So if I, for example, how would I do this?
X plus 7, X minus 7.
Yeah, x plus 7, x minus 7. All right. Cut everything in half, multiplicatively. Okay, I like it. And then the other one, the sum difference of cubes.
Yeah.
This is the weird one. So we're going to focus on this for right now, I think, just to kind of get it down more. Let me give you this handout so you can see if it's something you want to look at or not. when I give this to you, look at the very top. There's a quick reference guide at the top. Because then the rest of it is like really explained. Holy shit. The top is the quick reference guide. You cannot use this on a quiz or a test. So don't be too excited. Alright, so I don't know if that's helpful or not. If I were you, I'd have that sitting next to me as I'm doing my homework. Especially section 6.5. Because if you looked at 6.5 yet, even just to look at the title just to see what's coming, 6.5 is all the forms of factoring all at once. So 6.5 is a kick-ass place to go review, because that's exactly how I'm going to put it on the test. It's just going to be all the factoring forms, just like on the quiz today. So you have to be able to identify it and then do it. So let's focus on cubes. So to talk about cubes, I actually want to do well, let's look at the squares problem that's up here. Why was the squares problem so easy? Because there's how many of everything? There's 2 of everything. So I put one of each, minus, plus, I'm done. Why is it minus, plus, or plus, minus? Why is that needed? So the middle term goes away. Because I'll get plus 7x, minus 7x, yay, there's no middle term. I like it. So I know I'm wrong if it ends up with a middle term and there's not supposed to be a middle term. Yeah.
Would this be like that bonus question in the quiz?
Oh, the bonus question real quick, if it's still in your brains. 4 or more terms is grouping. So you should have grouped the first 2, the middle 2, and the last 2. GCF, and you end up with the same thing. See, grouping works no matter how long it gets.
And then you only write one.
Say again?
But you only write that, the one that came out the same, you only write
Because
that
there's
one.
only one of them. There's one of them that went to all 3 pieces, so there's only one. Yeah, okay. So that was the bonus, yes?
So where's this 49? If that number's not a perfect square.
Good. I love it. So if I said factor this, you would officially say prime. Let me see if you guys can handle. No. I sounded horrible. It's weird. Why is this 7? Because the what of 49 is 7. The reason this is weird is because we haven't really gotten here yet, but I know you guys know this exists. The square root of 49 is 7. I'm going to write this once. You don't have to write this. I just want to show you. Because you need a complete picture. I could then say that this is x minus the square root of 50, x plus the square root of 50. Do you want to write that?
No.
Do you want to think about that?
No.
So we just say, no, it don't work. We just say it's prime because the only way it could work involves non-whole numbers, right? I want my answer to have nice whole numbers or integers, right? So we officially call this prime, but just realize if we really had to, we could force it apart and make it look all ugly. Maybe. So if I give you this, y squared minus 11, what are you going to say? Prime. Yeah, sorry. Good, because 11 you can't break it up into whole numbers. You could break it up into square root of 0, but you don't want to. I don't want to. Okay, good. I'm okay with it, but I wouldn't. I'd rather not. All right, so then cubes, you would hope would work the same way. The one thing that doesn't work the way you wish it did is I don't just make 3 little dudes and put 1 in each dude. It just is not, it can never work. Because so like if I had x cubed minus 8, if I thought maybe it was x minus 2, x plus 2, x plus 2, it ain't, right? And the other day we investigated that. It just don't multiply out. It just doesn't cancel everything that's supposed to cancel. So the form is weird because it's got a lot of work to do. It's got to cancel all the extra terms I don't want. This is not weird because how many extra terms do I not want? Just one, the middle term. I just don't want the middle term. That's easy to get rid of one thing. This guy's got to get rid of two things in the middle. So of course the form is going to look worse. It's got weirder shit to do. Maybe. So my extreme suggestion is to write for yourself, break them both up. So x cubed is, and 8 is,
2.
I like it. So let's see what you guys remember. I put down here a little dude and then a big dude. I like it. So when you see cubes, sometimes when you write little dude, big dude, you start to realize what you got to fill them in with. You want to give yourself a prompt for the next step. That's why I try to make it sound funny, little dude, big dude, because sometimes it sticks in your brain, and you're like, okay, what goes in the little dude? Well, what does go in the little tiny dude? Yeah, one of each x. Minus
2.
2. So far, I erased my guess, but it looks like my guess, sort of, right? Except for this guy. Now, if I put 1x there,
X squared.
please let this make sense, because then what's x times x squared?
X cubed.
So far, my little intermediate check, I'm getting what I want, right? If I put 1, 2 there, I've got to put the other
4.
2 2s there, right? And I've got my, what is this? Minus 8. And then some people would say, okay, I'm going to stop there. Weird ass math dude. Because I got everything I want. Well, you got everything you want, but you got more than you want. That can't be the right answer, because I do get x cubed, check. I do get minus 8, check. But I also get
2x squared.
shit. And I also get 4x. Shit. Right? So that's why you can't just stop there. And it's got more work to do. It can't be 2 and 2 like the squares, because that job is a lot easier. This job's a lot harder, so we got to call in help. Again, I'm sorry if you've never seen Pulp Fiction, but I just love that example. We got Joey, need to clean something up. Okay. So it's always, whatever you put in the little dude, multiply it. Opposite sign. Why is opposite sign make sense? Because it's got to clean the shit up. It's got to be the opposite sign so it can cancel. So it'll be plus 2x.
Okay.
So when I introduced this, what did I just introduce? What's minus 2 times 2x?
4.
Negative 4x. That cancels. See, it cleaned that part up. I didn't want it, you got rid of it. No problem. And what's x times 2x? Because that's another new thing I just got.
2x squared.
2x squared. Positive 2x squared cleans that up. So let's do another one that's got a little more going on. Because you know you're going to get those, yes?
So that would be the answer.
Yeah, this right here, this very multicolored dude, that is the answer, that right there. This is me just kind of checking it.
So you just use the second term in the first one?
Yeah, whatever's in the little dude, multiply it. And then make it the opposite sign.
Okay.
Let's do another one. And another one.
Another one.
And another one. So of you guys get that? Alright. Let's try. Yeah. So let's go through the steps. Is there a GCF?
9. Oh,
No.
7.
No. 27 is made of a bunch of 3s. 64 is made of a bunch of 4s.
Then no.
No.
So no, there's nothing common. Right? You guys see that? 3 does not go into 64. Right? You guys believe me? Alright. So I understand. You want there to be a GCF because then all the stuff I'm working with decreases. But don't force something that ain't there. Poor little problem. How about the letters, of course? Shit, these are turning the wrong way. So, let me see you guys. 27W cubed. So what makes 27W cubed? 3W times 3W times 3W. You'll see why I write that like that in a minute. Don't put 333 www because then people start putting the 3's and the w's just anywhere. These got to stay together because it is together. What's this guy?
4.
Good, 4M.
4.
So a really good idea, I keep forgetting to say this, a little side note, you can't use this on a test or a quiz, but you need to familiarize yourself, that's easy, with all the cubes, so you know what numbers to look for. 3 cubed is 27, 6, yeah. 4 cubed is
64.
5 cubed.
125.
Good, alright, so those are the kind of numbers that tell you you might be working with a cube. Right, squares we basically know. We should know that up to at least 144, right? Hopefully. So like, real quick, a couple days ago was 4, 9, 16. 2 squared, 3 squared, 4 squared. You know?
Oh my.
Only math people would be like, you know, is the aligning of the squares, and we had a ritual and this stuff.
I have a question.
Yes.
27 I can divide it by 3 to get 3. But 46...
64.
64. Can I divide it by 3? I can't.
You're not dividing by 3.
I know,
I didn't divide 27 by 3
Yeah.
necessarily. I broke 27 up into its prime factor parts.
Yes.
Now 64, I'm not going to break up into prime. Let me say this differently. I broke it up into the same thing 3 times.
Okay.
Right? In this case, avenue is prime. 64, very often people think 8 times 8, but why is that not a good way to think of it? Because this is not a squares, it's a cubes. So 64 is just one of those numbers you got to realize. It's got 4, 4, 4.
So I have to learn something.
Yes,
like
you need to know that on sight. The same way you look at 49 and you know it's 7 times 7. That's a very useful skill. Well, you should be able to look at 64 and know it's 8 times 8 or 4 times 4 times 4. Yes?
There's an easy way to find out any number to divide by 3 or not. This is not for me. I know that since like 15 years ago. Any number, if we want to divide it by 3, it has to be a factor of 3. So 6 and 4.
Yes.
10.
No, we talked about that a while back, but that's not what we're doing, is it?
I mean,
Yeah, in general.
In general.
64 you can't divide by 3 because 6 plus 4 is not a multiple of 3.
You cannot divide.
We did talk about that, right? No? Like 45 is divisible by 9 because 4 plus 5 is
4 plus 5
9.
is 9. You can divide by
Any number that the digits add up to a multiple of 9 is divisible by 9.
It's only for number of 3s. Right?
Well, that one rule.
Yeah.
Any number that ends in 2 numbers that are divisible by 4, the whole thing is divisible by 4.
How? Can you say that?
So that's another rule.
What is
If the last 2 digits in any number are divisible by 4, the whole thing is divisible by 4. Yeah. So there's rules for everything except poor little 7. There's no rule for 7. 7 is a weird little number.
That's why it's a lucky number?
It's a funky ass number, yeah. There's no rule for 7. It's just 7 does its own thing. Whatever, 7. All right. So how do I start to build? So we broke this down.
Okay. Now,
A little
three
dude,
big
big
dude.
Little dude, big dude, I love it. What goes with a little tiny dude?
3 1
One of these
3W
plus
plus.
4 N.
So what goes here?
9 W minus.
All right, let me stop there for a second. Let me make sure everybody's with me. Does it make? I really want this to make. If you put one of these here, the other 2 have to go there. So that overall, what do I get when I multiply these? 27 W cubed. Check. You can just kind of keep track that you're getting what you're supposed to be getting. So if I put 1 4 in there, then what goes here?
16 M square.
Oh crap. 1 of each, 2 of each, product in the middle. I don't like making songs, so there. Yeah.
Negative 12.
Good. Opposite side. Got it. Opposite side. Multiply. 12 WM. I love it. That's fine. It feels like cheating. I understand that. But you can actually... We're not going to go through the whole... But you can actually kind of prove that this works. But I just like to instead show that it works enough times that you're with it. Here's the nice thing. The big dude can never be factored. So don't even waste time trying to factor this. You can never factor it unless there's a GCF you left in there. This will never factor like that. Ever, ever, ever. So don't even waste time. So here, you guys try this one. two even. What's that? I just know those numbers over there, right? 3 letters, and then one of those numbers that I'm gold. This is one of the problems. Normally I tell students like 10 minutes before you take a test or something, you shouldn't look at any math, because then you're just going to start to second guess yourself. I forgot that. I forgot, oh shit. And then I give you the, But this is one thing I would say you should just be doing several of these right before you take something, just to get the form in your brain, because it is a quick one to leak out the brain. So how do I start this off?
Small thing.
Yeah, so y, 5.
5 plus 5.
Yeah, little dude, big dude. I like it. So 1y
Plus 5.
plus
5.
5.
Y squared.
Negative 5.